Hello, hello, my dear friends, and welcome back, everybody. Long time no hear from me, so my Linux problems as usual. So hopefully I'll get my MacBook soon, and you'll be able to stream more often. But what is our task to do today? So according to our Discord chat, we have two most demanding features which I have to implement for the next version, 2024.1, and meet our two friends, two feature requests. Basically, this one we are going to implement on the stream, PROTO payloads between RoadRunner and PHP worker. So I'll explain what was the problem and why we need to implement especially PROTO payloads between RoadRunner and PHP worker, and what is the transport used to do this stuff today. Let me use my board, Xcode draw mode, and here you are. Yeah, so currently we have RoadRunner, yeah, surprisingly, and RoadRunner connects to worker via three different transports. First one is pipes. Why so bold? Like this, pipes. Pipes, everyone knows what is pipes. So we have file descriptor, and we have a process, and every process have even like. Let me make a music a little bit quieter. So every process I doesn't care about file network, every basically process is a file inside the Linux, and every file have three basic file descriptors. There are 1, 2, and 3. Std in, out, and error. So basically std_error is used to have is used to push logs, and inside runner we use std_error to push especially logs from the worker. So if worker put some information which should be shown to the user or should be saved in the logs, so basically we use file descriptor std_error. These two file descriptors, std_in and std_out, are reserved to for internal communication between RoadRunner and worker. So basically worker push some data into std_out, this is std_in, and runner reads this data, and bidirectional communication. So this communication is done using let me just remove, I don't need any promotions. Thank you very much. If you I can't read this. Okay. So yeah, basically this abstraction used inside the pipes, and this communication is done using frames. So frames are something like TCP/IP frames, but in our case this is a frame of information which can contain up to 4 gigs of data inside it, and it has version inside it, 4 bytes, I think, 4 bits, I'm sorry, 1 byte of version and a header length. Let me see this inside our repository. I think it's inside frame, yeah. So basically this is how our frame looks like. So we have a version, we have a header length data, so which indicates how much data we have inside the header. We have a flags which can indicate different kind of things like payload length, so you can basically put inside flags whatever you want. We have a payload length, which is like 2 bytes. We have CRC. So this is previously we had header CRC is only 2 bytes because we wanted to use CRC, I think even 1 byte, I guess, because we wanted to have CRC 8. So I thought that this will be sufficient, like to check the CRC sum of our header, but implementation of CRC 8 inside a PHP is super slow because we have to implement by ourselves without using like intristics, CPU instructions, and etc. So yeah, so if in Golang part CRC 8 on our data was faster, but in CRC 8 in PHP was significantly slower. And we moved to CRC 32 because CRC 32 in PHP implemented via the process instructions and via bindings to PHP runtime. So basically via C. Here we have also information about streaming, so everything related to stream, like explanation, located here. So basically I'm just repeating this information under this explanation here. So stream, currently we have streaming responses from HTTP plugins. So in this case we definitely had to implement some kind of like put some bytes inside our header to indicate streaming information. So stream was started, stream was ended, so stream is continue, like ping, pong, all of this kind of information which is related to streams. And relative options. So options, which is also can be like, for example, RPC sequence ID, because RPC like used as sequences, like 1 you should answer 2, 3 you should answer 4, and etc. and go so on and so forth. And so we this is like likewise in TCP and IP-TCP protocol, they also have options. So yeah, if we have a header len indicating that we have an options, we should cut off these options and then parse these options one by one. So one option is 4 bytes. So we should cut it by 4 and use this information later. So basically inside in options we use separator between inside the payload. So we have context and we have a binary data. For example, context can be headers from HTTP request, for example. So this would be a context. So we have to put some length inside an options to know that we have to separate and to split this data between, so like it would be a context and binary data which sent a user for us, like yeah. So basically this is a frame header which we have inside the RoadRunner, and we communicate all like kind of communication between the RoadRunner and PHP worker is done by using these frames. They are pretty fast to pack and pack, and you will see this super kind of performance way I wrote using all of my Golang and C knowledge how to do it faster. So for example, you might see this checks. This is bound check elimination checks to prevent compiler to check that we have this actually data. We like preventing inserting these instructions into the binary, checking that we have zeros byte inside the header. So which our header length is more than 0 bytes, like it at least have 1 byte inside. So this saves us a few nanoseconds, you know, but this should be kind of super performant. So we use binary shifts, we use like ands, ors to like be as closer as we can to machine instructions. And we also have this where are you? where are you? So yeah, Golang compiler can't unwind loops. So if we have a predefined number of, basically we can have only 40 bytes of a payload. Here in the inside frame, you may see that we have up to 40 bytes. So we can't have more than 40 bytes of options here. And what is interesting, if we use just a for cycle, so for loop, we can do this basically, because so why not? Yeah, Golang, while you are reading these options, can't unwind this loop to understand that we have only like let's say 10 bytes of information, and we should do these shifts faster. And here our implementation of loop unwinding. So I just set this loop directly eliminating every bound check, eliminating bound check of for the options, and manually, so unpacking like first byte. If we iterate in the next option, and so on and so forth. And using this technique, we also save like few percent of speed of our performance. So this kind of stuff written in a super kind of performance way. I also have to somehow rewrite this checksum EE because it's also written in a generic way, but we can also have few percents of performance from our frame parsing logic. And this is done only to have a super kind of fast packing and unpacking mechanism of our frame. And we also have I also put a logic which I called size classes, because very often we have super small payloads like up to 1 megabyte, and this would be cool to pre-allocate some space, to not allocate the memory, like, because we have a limited amount of memory, not on the latest MacBooks for sure. 120 gigabytes of memory. This is definitely not for these MacBooks, but if you have like most servers have a limited amount of memory, and here you using like size classes to have most of them would be up to 1 megabytes, and this is pools, pool of up to 1 megabytes payload, and we allocate these slices of data, and then how we read them. Where is it? Where are you? Should be somewhere here. Yeah, we're reading them, so we read the data inside this size class, and then read up to bytes we have inside our options, which with our delimiter between the context and byte data. So we use only one system call to read all the data. So, and then put this data back into the sync pool. I know this is kind of complicated logic, and my explanation is not super cool to understand what's happening under the hood, so feel free to. So all of this is open source, and you can just get into this code and like debug, because we have tests and debug and understand what's happening inside. But yeah. Basically, we have these frames. We have also TCP and Unix sockets. So TCP is slowest, and it is used in a places where you just like by some reason you have to debug, because if you put some data in non-frame data into first and second file descriptors like std in and std out, it will lead to error. Like, I don't know what kind of error, but it will lead to, from the RoadRunner part, it will lead to error kind of. So we can't read this frame because it's like just random bytes inside it. It's not our frame, it's just your data, your log or something. Inside TCP, you can do this, and you can see the data, so even if you put some kind of random data. And Unix sockets are quite close to pipes in performance terms, so you can basically use pipes or Unix. So no configuration is pipes, because you don't need to configure anything related to the creating socket, like putting a path to it inside the configuration. And yeah, with pipes you should only say to RoadRunner like use pipes, and that's it. Okay, so today we're going to implement this proto payloads between RoadRunner and PHP workers. So, and yeah, question why we need to do this. Here we have a worker, and previously, so we had a JSON communication between RoadRunner. So frames either binary, so frames used like a binaries, but the data inside frames, like here, packed as JSON. So for example, if you had some picture, for example, you wanted to send a picture from the, let's say from Nginx, or upload a picture, you have to use base64 to pack this picture inside a JSON, because otherwise, if you put like raw binary data, JSON will just break it, because it will replace with like these symbols like U0012, so it will use HTML escaping and escape all of these kind of symbols, and when you save this file on disk, it would be just like broken file. So you have to pack it into base64, and we have this problem for a quite long time at the moment. And so currently on the PHP side we already have this implemented, so support for PROTO. And for the PROTO, with PROTO, we don't need to use JSON anymore here. No JSON. We can use PROTO, which support for sure any binary payloads which we wanted to send. So you don't need to use base64 anymore. You don't need to care about this. You don't need to care about like Slack, for example, which sends a data and which is also escaped if you like try to pack it using JSON. So PROTO is our way to work at the moment. This feature will be available under the new experimental flag. It will be available, I think, very soon. So using RoadRunner -e will turn on experimental features, different experimental features, not only this one. Okay guys, so now let's get into IDE and let's get our fun part. So basically previously we had let me just uncomment this. We have this structure which represents our request. So first of all, we need to use, where's our API, please? Okay, here's our API. API contains all of PROTOBUFs which we use to communicate between the RoadRunner and the worker, and especially also between RoadRunner and an award, because we also need to communicate via RPC, and communication via RPC is done using our codec for RPC, which supports PROTOBUF. It's kind of similar to gRPC, but without needed of, so you PHP user don't need to install gRPC extension, so it can be used without installing this extension, because it's as far as I know, it's kind of very slow inside the PHP. So you don't need to do this. And here our representation, it's kind of similar to this one. So our request, our uploads, response, and etc, etc. So, and the funny part is that we can't use HTTP request anymore here. So we can't just say like HTTP proto request like this, because we don't have is not like it's not local type. So this is not our type, this is generated type, and so we have to use a famous Golang technique called move one structure into another. So it's very famous Golang part, because like in Golang, so even if you have two pretty similar structures, one of them have let's say some kind of non-comparable field function, for example, you can't just assign one to another. You have to like assign field by field. And here we have definitely non-comparable, because we have some kind of ANIs, we have pointer to uploads, and yeah, so we have to put one structure, this request, into HTTP proto request. And let me check. This is, by the way, HTTP plugin. HTTP plugin, which is located here. So we are working currently on this plugin. This is, I actually don't like this plugin. This plugin is written, was written very long time ago. Let me just remove this. Let me just make it like it was before. Give me a second. This plugin contains a lot of things which is not a Golang way, actually. So first of all, we don't need to parse multi-part data by ourselves, because I don't think the RoadRunner should actually involve in this part like so deep, so in this parsing, because this kind of stuff actually in Golang is done using middleware. So if you need to parse some data, so use middleware, and it would be like much easier to understand and to, let's say, prepare some data, then remove this data, and so on and so forth, rather than using some kind of things that we currently have in our HTTP plugin, because it's like, it's super big plugin, like contains a lot of things. Like it contains fastCGI, HTTP 1.1, HTTP 2, and HTTPS servers. So a lot of things combined in one plugin. So it, for the like some kind of guy who wanted to contribute into this plugin, would be very hard to understand what's actually happening. I tried to put as much comments as I can, but yeah, so this handler, for example, especially very hard to understand. And this is kind of good question can arise in your head. Why I don't use defer? I use defer quite rarely in the RoadRunner. First of all, because defer like have its price, let's say like this. So defer in this kind of performance. So RoadRunner shouldn't be appeared on a monitoring systems. It shouldn't be like UPHP script use, let's say, 10 megabytes of memory, and RoadRunner uses like 5 gigabytes of memory. So or RoadRunner, like UPHP script executes some kind of request for like 100 milliseconds, but a RoadRunner part is like 1 second. like where you like get request, process it, and push to the worker. So it shouldn't be cost of the using RoadRunner shouldn't be like bigger than executing just directly payload on a PHP script. And run should be like a ghost, like it have. So you have RoadRunner on the server, but you don't see it. You like basically monitoring system sees a ghost. And that's why I'm not using differs, because differs have their price like for I think 100 nanoseconds or even milliseconds of using differ, but in our case it should be like a lot of differs. And this can lead to errors for sure if I forget, for example, to put payload, to use this hput payload with payload. Yeah, but this is quite stable and well tested part of the RoadRunner. Okay, so where is request? Where we, let me check. Here we prepare request, and here we execute it, payload, and request payload. Oh yeah, this is the part where we put prepared data, already prepared data, from the request to the payload. So because RoadRunner internally accepts a payload, which is consist of like 4 fields. They are context and body, which I explained before, codec, which codec to use, like we have to defer or not to defer, definitely. And RoadRunner option is not to defer. So inside we also have a codec to use, like JSON, PROTO, MSGPEG, or raw bytes. And we also have a flex. Flex indicate, as far as I remember, about streaming. So, do you have a stream? Do you have a ping, pong, on like this? So basically, flex are it's only 1 byte, so not more information we can put in this flex. We basically use masks to unpack this flex. Okay, so and this is where this JSON happened, as you may see. So we parse body, we parse this body into JSON using another map, so without any order. And yeah, this is kind of ugly. So currently we should have a PROTO. So first of all, let's introduce a new option, because we also should have a backward compatibility for our users. And our option would be let's say it can be like a PROTO, just a PROTO. We don't need raw body anymore, because every payload would be raw when we implement this feature. And we can replace raw body with, let's say, with PROTO. And by default, PROTO will be set to false, because I don't want to break existing application. That would be like, you know, no one wanted to break anything. And yeah, uploads OBS is. Here we also don't need to do anything. And we have to do the job, like put previous request into the new one. Okay. And also, as you may see here, I return only error from this function, payload. If you have, also, it's not a super kind of performant technique, but if you if you need your result in currently in place, and you can use pool to sync pool, I mean, and you can use sync pool to have some kind of storage of your payloads, of your data, of you, like, so whatever you want, like your structures, to pre-allocate some data in and not to use a lot of memory inside your application. And this is because we can't use pool here, because if we use pool here, we have to put this payload back into the pool and then allocate in new one and then return it. But in our case, we passing a pointer to the payload from our pool. We passing a pointer, fulfill it with data, and then pass to the our execute function. And after this, we can safely put payload back. So allocation happened only once in this scope. Not twice if we like use payload as a return value here. And also we have some pre-allocated space, which is kind of cool. Okay, and according to this logic, it would be nice to have a pool with our HTTP proto, but for the sake of simplicity, let's proto HTTP. Forget to edit. So this is, I configured this distro just a few hours ago. API version 4, build HTTP version 1 beta. Let it call us HTTP proto and request. And let me pass it here. Okay, so, and here we can feel it. Okay, but before filling it up, you have to somehow pack it, because oh yeah, we have an agreement with Alex that I'll put everything in the body. Yeah, so in a previous implementation we had, as I mentioned before, as usual, yeah, a context which contained the whole request with its these fields. And nowadays, and body with only body, but nowadays we have this super cool request message, proto message, and raw body we don't need it, bye bye. And we can basically just pack everything inside it and pass as a one piece of information. So we actually don't need context anymore, but we need to prepare our data. What is this? Why? By the way, I hate this new UI. I forgot to tune it off. This is so ugly from my point of view. They forgot about their, so JetBrains forgot about their main purpose of creating good IDEs and started to do these ugly UI experiments. I hate it actually. So I'm planning to use, I'm previously use Vim as every cool developer. But I have problems with it with debugging, and I recently I solved all of these problems. And when my Mac arrived to me, I have plans to forget about JetBrains because it's like a pain for me. Where this one dark, please. Why are you white? Stop. Oh my god, sorry guys. This is one dark. I don't believe it. This is not a one dark. Oh yeah. Good old JetBrains. HTTP. Yeah, so we don't need to put any data inside the context anymore, and we can safely just comment. But we also don't need to have raw body because everything is raw at the moment. Or not. Body, but yeah, so everything is raw at the moment. So we actually don't need to use even this parsed flag because yeah, we actually doesn't care about it. Oh yeah, it might be used by PHP. Yeah, flashbang. Yeah, it might be used by PHP, so we definitely do need to leave it at the moment, but we don't need to use it inside the RoadRunner. We only need to set it. Where are you? Oh yeah, this is used inside multi-part requests. Or what? So return nil. Oh, the only case where we set this flag to false. Actually, we are not touching it. Actually, here, if we use context stream and read all of this data, and we don't need to set it here. Why? Because if we have a stream, we actually return nil here. We don't care about this flag. But if we use multipart, content URL encoded, anyway, we'll set this to true. We can set it here to true, or we can set it here to true in case of this URL encoded. And you can now understand why I wanted to rewrite all of this shit, all of this plugin, but it's so big, it takes a lot of time to rethink and to rewrite. But I'll definitely do this on the stream because this is the most used plugin in the RoadRunner, and I'm scared about the quality of this plugin. It was like moved from the RoadRunner 1 without, minor changes. Okay. Request parsed is true, so here we can't. If yeah, and also quite a good technique. Previously, we have to have this unsafe string like parsing. Oh, this is assembly implemented function. Cool. So previously, if you think about allocations, you definitely will think about binary bytes to string and string to bytes conversions. And when you do this, you always allocate a copy of, like if you use like notation like this, string, a byte, or vice versa, you will allocate. You will allocate new data where it would be copied all of this previous data inside a new container. But this, if we don't change this data, and we don't change this data, we can use slice header. So because basically, I'll show you. We have two types of headers: slice header and string header. Actually more, but related to our question, we have two headers. So these two headers represents an internal representation of slice and string. So for example, for the slice, it would contain len, cap, and data. uint ptr, uint ptr, and uint ptr. So it will contain 3 pointers. I'm sorry. I think no. I'll wrong. So no, not like this. These are ints, just int and int, and the data uint ptr. Why? Because we have length property of the slice, capacity property of the slice, and we have a pointer to the underlying data container where our bytes are located, like zeros and ones. So we have a pointer to this location, but inside a string, what's the difference between slice and string? We don't have capacity because string don't have this property. String only have a length, so we don't need to inside a string say like, okay, this is our length, and we have inside our like allocated, pre-allocated data like storage, we have also freed some kind of bytes which should be addition as capacity, like this would be a capacity. So capacity will be bigger than length. And so since we don't have this kind of pointer, so you can represent this like a pointer, you can't directly map string on a slice because string is smaller according to data locality and structure data locality. But vice versa, you can do this because it's like a bigger, you map bigger on a smaller. And previously we have to do this using just like manually, like allocate two headers and then parse and then like apply one to another and etc. But currently, thanks to Golang gods, we have these methods: unsafe string and unsafe slice. And these two methods like were as a response to demand and to voice of the Golang community, please give us like a library and standard library methods to parse strings and bytes without allocating an additional data. Because in our case, why I care about this? Because in our case, this B might be quite big, and like for example 1 megabyte. It's like you may think, okay, 1 megabyte, it's too small to think about this. We are in PHP. Man, what are you talking about? 1 megabyte. Our script have like 5 gigabyte memory consumption. You care about 1 megabyte. So, but if you have, let's say, 100 requests per second, and you allocate 1 megabyte per second times 100 or 1000. You can imagine the load on a garbage collector, on a going garbage collector. And as a result, part of the CPU power will be consumed to like collect your garbage, but actually my garbage, which I allocate here. So to collect my garbage, and according to specs, Golang can allocate up to 30% of CPU to collect garbage. So it can allocate more, like in general situation, for sure. And so imagine that your application works, and like RoadRunner like constantly allocate third of your CPU power. It would be like quite surprising. And this is why I'm very often use this string to bytes. But the very important thing which you have to understand using this technique, the data shouldn't be touched anymore, because I'm sorry, something with my headphones. Oh, yeah, good. So, because if you touch the resultant data, if, for example, if I touch this and try to modify the data inside this body, the pointer, as you remember, as from slice header explanation, will be just copied. So you'll touch also the data you tried to copy in the previous step, like here. For example, if we have some string A, B, what is kind of string? A, B, C, and you currently have a byte with like A, B, C, 3 bytes, and you'll try to modify B, and let's say to modify it to D, this structure will be also modified. You may say, who touched this data? But if you use, for example, I have one example who can touch this data. For example, logger can touch this data. It can modify a data when it writes the data inside as like std_error. And especially Zap logger can touch this data. Boom, and you currently, if you touch this data, this works in both ways. If you touch this data, you'll modify this slice, so like this one should be. And if logger, let's say, modify somehow this data, like create a JSON from it, you have a JSON here, which is not expected for sure. And I had this error previously. Hello, Malvia Himansu. Sorry if I pronounce your name not correctly, and thanks for following. Enjoy the stream. Say goodbye to Zaplogger. No, actually, so we have this ticket about official replace with the official one, but I'm pretty sure that any logger will touch this data. So no one expect that you have the pointer to the underlying data in somehow operating with it. So it would be super unexpected. And how to prevent this? And a good question here. Hello. And a good question here is, how can you detect this change? And how, because you can't just rely on a Golang race detector, yeah, when you're running like script with a race flag, because these two things are equivalent, and if you're not using a coroutine, that would be fine. So if you modify the data in somehow, you should use an finalizer to detect where your data is stashed. And so I have this. Let me show you how it looks like. And you know, so we have to think about this to make RoadRunner to be a ghost on your server. Don't show me this again. Pum, 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 pum. Where do I have? Yeah. So, and race check is ignored. I know that it is ignored because it used only when we built RoadRunner with the race enabled. And as you may see here, we like on purpose starting this coroutine here to check if it's still constant. And if so if someone writes the data, it's SHA 512 will be changed and will be not as same as the previous, and we will detect this mutable access and print the guy who do this in the logs. Like we know the address of this guy and we print who did this, and like blame on you why you did this. And especially this is the guy who did this previously as our logger. Where are you, logger? Where is the right method? Yeah, here you are. And I put a comment here that this is unsafe to use utils as string. Utils as string is our previous implementation of before introduced standard library methods. So we used our current implementation, our own implementation, sorry, and it's not safe to use here. And here we especially creating a copy because this data which arriving to us here in this write method, yeah, it's somehow, you know, previously used in unsafe conversion. This is why it's called unsafe. Okay, guys, let's move forward. Boom, boom. So I don't know. So do we need to this send raw body? Why I'm thinking about this? Because currently we can safely parse the data, yeah, and use the data as like a binary representation of this data. So we are not afraid of JSON anymore. We're only afraid of our hands, our crunch hands. I don't think that we need this anymore. We can use this post form. I'm thinking about users which can be touched by this change. I don't think that someone will be affected by this change. I don't know. So basically what we're doing here, if user requests a raw body, why this option actually exists, raw body? Why it exists? Because previously to avoid this problem with JSON and like base 64 parsing, we used this flag raw body, and using this flag we just like pass the data as is. And I think that I don't know. If the data is URL encoded, yeah, so we can definitely skip this part, because if the data is URL encoded, we'll definitely have some result from this parse form, yeah, and we parse this data and put it inside the request body, yeah. And which is we can use how we can yeah, so we have two problems here. Problem number 1 and problem number 2. Any and any. We can't represent any type in a protobuf. We can represent a JSON by just like JSON Marshall, everything you see in this attributes. We don't care about it. We don't care about it. But inside PROTOBUF, for sure we have Google's any type, but this is not the same. It is not the same. It is not the same as Golan's any type. And we definitely should data tree. And this any. I hate this any. It resembles like I think about any and PHP, so this is kind of a piece of PHP in a Golang. So we shouldn't have any because we have types. Why should we have any? And we definitely should eliminate it to have our proto be happy. Data tree and any. Push fish indices, mount. They are string. They're strings. If we use like this. And we can do like this. Data tree notifies type. What is our DT keys? So what is this logic? In this logic we basically parse this kind of notation, which is URL content notation, and we parse it to represent to PHP as already parsed. So you don't need inside the PHP to parse all of this data, you know, once again. So we can pre-parse, let's say it in a Golang, which would be significantly faster if you try to parse it manually inside the PHP. So we just do a job for PHP here. And the problem here is we have data tree, we have keys, and f is a string. And yeah, so f is a string, and we can parse, and we can okay, and we can't use like string as data tree actually, but element inside the data tree is a data tree. But oh my god, what the shitty code I wrote. It was written a long time ago. You know, this is the case when you return to your code. I didn't draw this code actually, so it was written by other guy. But this is the case when you start working on a code which is written by someone else from PHP world, and it's like my eyes like, why you wrote this? In Golang we do differently. You shouldn't do like this. It shouldn't be a lot of parsing here, like mounting and recursion, since you can check. So you definitely can check from my algorithmic point of view. So you definitely can have it can determine maximum depth of the tree, and you don't need to use recursion in this way. So if you know maximum depth of the tree, you can just iterate using the maximum level without this like mount, because this is recursion, and this basically icon indicating this is recursion detected. I hate recursion because using recursion actually in a significant number of places it can be avoided, because if compiler can't statically understand that your recursion can be unwinded using some patterns, you won't have any optimizations from the compiler in this way. But I want to have optimizations. And the problematic thing here that we putting inside our tree, we can put a string, and we can also put the data tree itself to parse on another iteration. Oh my god. And this is why we had any type, which is actually string type. Okay, where is mount? Okay, what kind of type we can have? We can have a string. This v is a string. We can have okay, v is also string. If I put a string here, oh, is a string, slice of strings, and this is a string, and this is also string. Oh, no. Slice of strings. Okay. And at what point we put... Oh, yeah, I see. Here. Hello generics. Tree. Yeah, so it can be data tree. We can be a string of file upload. Oh my god. So ugly. Why? So basically I'm thinking how to eliminate this, because T can be data tree or file tree. For sure, we can split it into the data tree and a file tree. We can split it into a string and a file upload. But we are not eliminating here this. Oh my god, so why it's so ugly? Why it's like... Oh my god. Why it's defined as a top level keys? Why defined here? Why not to use a structure? Oh. Hello PHP, like this code was written by a PHP guy. So okay, let's redesign this. So since we are trying to use a PROTOBUF, let me check once again. So first of all, I wanted to eliminate this entirely. We don't need to. So the worst you can do in Golang is define something globally. This is wrong, because you can't test this properly. You have to clear this up every time you access to this data tree. So you can't test this correctly. So you basically can do this, but you have to track between the tests. You have to clear this data structure, clear this up, because on every test iteration, this data tree will be fulfilled by the previous data if you use it globally. And yeah, so we have this. We only have oh, we have only type aliases here. Might be this is not as bad as I'm thinking. We have data aliases, and we have this function of this data aliases. So because why to use data aliases here? Because we can't use map string as a receiver for our function. So you can do this. Okay, this is harder than I thought before. Okay, so this is fine. Okay, having data aliases is fine. I'm just mistaking this with like global type global structure declaration. But still, what is bad with this such kind of notation? Because data tree struct, we can't do like this data tree. For example, thank you ChatGPT, you're just doing what I'm thinking about. Data tree representative common request. Okay. So the problem here that if we are using a structure as a solution, I'm sorry, map string and let's say string, because string is a slice of strings is a bigger scope, which can happen here. We can have several strings from in our payload. We can have one string as well, but oftenly we have a slice of strings. And what is more important? We can use this like this. So we can safely use any inside this one if we wanted to, you know, pre-process the data, and we wanted to use this case if it's not a string, if it's not a string, if it's not a slice of strings, so those we have this data tree. But also we have to check this. It's not safe to parse, to assign like this. In this case, yes, we can use any here for the preprocess, but as the result, the advantage of using structure here, but as the result, we can use a tree. And in this way, if we have slice of strings or another slice of strings, we can put them into our tree. But if we have another level of data tree, we can use a preprocessed data here, you know? And in this case, we will not use some kind of cycles to loops to put the existing data to check it, like, you know. This will be a slightly more let's say memory inefficient. Like this, and we don't need to use this anymore, data tree. So let's see. Okay, and our new method. Let me call it parse multipart data 2, which is going to return tree, data tree. I don't know if this a proper name for this structure, but we can change this later. Okay, so here we have to allocate our structure. We can also, we can also use our technique and pass the pointer to the data here, like this. Boom, and we eliminated one allocation. Here, data tree. I think we don't need to allocate data inside this. And let's do like this. Data tree and data tree and I'm not going to touch file tree at the moment, but yeah, we'll touch it later. And we can do like this. Data tree keys 0 is a V. Let's just comment this. ChatGPT helped me. Thank you very much. Thank you very much. So appreciate your help. Wrote the same. And here we have a slice of strings. Why should we as a string, we as a string, we as a string? And now super technique. And we also don't need to cast this anymore. Boom, boom. How we can do this? Strings and string, and here we are return data tree preprocessed tree like this. Oh. We should do it like this. Where are you? Yeah, so we actually can't do like this because we don't have a mount method on the data tree. We have mount method only on our new structure. Yeah. So we know currently that the value of this operation is not a string, but data tree, another nested level of the data tree. But we can't use if you use our structure here. What? Oh, yeah, we can't use this. It's generic. Okay, we'll resolve this later. I don't want to, to overcomplicate this logic as well. For sure, we can use some channel and, parse all this data, put like the results into the channel, read from the other end, and fulfill our structure. But maybe just to create a proof of concept, we can return string, slice of string, data type here. It's just so what I wanted to avoid. I wanted to avoid another loop here like this for blah blah blah, and like put the data from the data tree into the like another structure, into the like map string, and here is string. So I want to avoid this loop here, because for sure we can leave this as is, as it was previous, but we can like modify this payload, return, for example, let's say type data tree 2 like this, and return data tree 2 like here, which would be already parsed. But I don't want to do this. I want to do this in place. I can't do this with this type aliasing here, because you can't add anything to it. But might be we can use here. Oh, let me think. Let me do like this. Type type data, let's say struct, and we can have tree here, or not payloads. ChatGPT think better. We can have data as a string, yeah, and we can replace it like this, data, which would be typed, and data is not a good name. Data would be better, definitely. So this is for sure, this is temporarily given name. But this is like everything temporary can be in the production in a second when you forget to when you forget to change this name later. It can be definitely in the production. Okay, let's move forward. So we eliminated any. We can return this type here. We don't need this. And yeah, we don't need this one for sure. And let's think now in this way. Here we don't need this. And boom, data is no. key. Why you can't? Why? It's because of map. Yeah, this is we should, yeah, so when you're using maps in Golang, you actually can't do like this is equal to something, because you have to get this type. You have, because there are concept of addressing addressed and non-addressed things in Golang, and map is not addressed, so you can take an address and modify the data inside it somehow. You should put the container and put the data directly into it. And okay, let's boom and d data is v. No? Yeah? Thank you very much, ChatGPT. Okay, and here we already know that we have a tree. Oh, we also can do like this. Tree dt keys tree, and oh, we don't need to do this casting anymore. Yeah, like this. Like this. And yeah, and we can't use T anymore here because T is a complex type. We can't use make T. We should use because it's not because it's not a data tree. Or why? The function declaration declares type parameter. This type has no single underline type. Okay, so we'll get to this later. Oh, this is only 2 errors here. Okay, let's see. Okay, guys, I'll be right back. Give me a second. And I'm back. Okay, let's see what we can do here. Since we so I'm a little bit worried about this notation, because I'm thinking about how we can relocate this data. Okay, so previously we had any here. Any can be the following type, of the following type. Any can be another data tree, or any can be a string. So basically there are two types, which so we can replace this with a generic. You know, we can replace basically this with this generic, something like this. No, we can't. With a union, might be type, union interface, data tree or string, and put it here. No, we can't. Oh. For Golang generics. Okay, we can do like this. Okay, I understand. I'm a little bit worried about this kind of notation because data is not a pointer. I'm worried about that we are changing this data only here in place without changing this inside a map. I forgot. Yeah, so this is like a Golang easy language. And here, if we have a data, then tree okay, is first of all we should store a pointers here for sure. And I think, oh no, data, no, we should have an indirection. No, still not like this. Okay, but using the pointer, I'm pretty sure that the data will be changed in place. Okay, so another case is a data which is data is a string. Okay. Why it's nil? Ah, this is slice. Yeah. Make like this. Also, quite an interesting thing. If you're using like, let's say 0, 10 for the string, this is fine. Go take into account your consideration of pre-allocating a string. But if you are using, still we can do like this. Okay. If we use annotation, why it's not delete? Oh, annotation like this, and data tree is a map. Go. This is only advice for Go. Like, would be cool to have, let's say, 10 elements pre-allocated inside. I'm just like suggesting you to do this. Golang can say, oh yeah, based on the demand of the memory and how much memory currently we have free. So we refuse your suggestion and allocate 5, for example. So this is only suggestion to go, while this is order. Allocate 10. This is please allocate. This is like a Windows and this is Linux, you know. How you kill processes inside the Linux. Please kill this process. Just shoot. Linux and Windows. And here, you know, here we're in a bad situation, you know, because tree in our case is a generic type, and it can be data tree or a file tree. If we use a file tree here, they are the same basically. Why we should care about? Why we have two same type? Good question, you know. We don't. We shouldn't have. We don't have, as you may see, and we shouldn't have this two types. For the file tree, yeah, I know that we have a slightly different, you know, slightly different methods and methods for the file tree, yeah. But basically they are the same. So why to have two same types? Why to have two type aliases for the same type? Just why? Why not to reuse them? Might be this is because we can have different things inside it. But let's see. And we don't need to use a tree only like this. Is not a type. Oh, we oh, no. Sorry. Like this. It's not a type. And this is type. Yeah. Tree. My God. So this is so temporary code that, you know, trees. This is how you wrote like a code when you just wanted to check the idea. Tree, please, tree. And we actually don't need to use a casting here. And in this case, we also have to use like this. Am I right? Yeah, and this we get into the not very good situation, because inside we have different mount techniques. Why different? Let me check. I think they are not different. The different thing is only in this method. Prepare tree nodes. Yeah? And what about this method? Let me check. Okay, they're pretty much the same. Yeah. So except to this oh my god. So this is I think I wrote this method because I do like use switches instead of ifs, because currently you have branch predictions and you can basically predict in what case you can jump. And we also have tables, jump tables, where we can immediately jump. We don't need to super like check all of this, but in this case for sure we should check, because we don't have predefined condition here inside the switch. In this case we lose all of these advantages. But if you have if you know the condition here inside the switch, it's better to use like for example, but you have different types which you can parse, like notation like this, t foo dot type. So it's better to use switch instead of using ifs. It would be faster, in some cases significantly faster. But let's return to our i0 I string. Yeah, key is also string. Oh, yeah, I found it different. All of this is strings, but in case of, yeah, we have a file upload. Yeah, okay. They're not the same. They are slightly different, you know. They are the same in case of, okay, this. Okay, ChatGPT. Good try. Next case. Go to, yeah. Just tune in. Yeah, I also forgot to put a return here. And the last one. You my genius. Slightly shorter. Okay. And we come closer to the answer on question why do we have two same type aliases here, because we have, so this is so stupid, because we have methods on them which are slightly different, just only slightly different. How we can merge these slightly different methods into one big generic. So we have a slightly different push method, because here we have file upload, yeah, and we can have file upload or slice of strings. Yeah? Pum, 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 pum. So we can basically write like this. Here's my super generic function. Whereas we can't actually replace this. Okay, so whereas T is string or file upload. And like this. Can do why? Oh, yeah. So we have to write like this. Where we should write oh, sorry. And mount. Like this. Yeah, so we have duplicate. Oh, not this one. We just temper. Method cannot have type parameters. Oh yeah, because this method of this is a property of a tree, so we have to write like this. Or we should use generic inside this tree. And we should use this as a string, or let me check. Let me uncomment this. We just like destroying this sparse logic. So at the end it would be like two different like files entirely. They are super similar one to another. So the difference we have is only in this file upload. And since we have a difference in only one thing is a file upload, we can generalize this, I think, like this, where T is string sync or file upload, and this can be T. Yeah? At square bracket. What? Why I should? Do we need to have a type alias here? Or we can use this. I'm actually don't quite. So I used Gong generic quite rarely, and because they are, from my point of view, compared to Rust generics, because I wrote a lot in Rust for sure, like, and compared to the Rust generics, Golang generics are quite harder to understand from a point of view. And let me double check any tutorials we have at the moment, because I understand. I particularly I understand why we should have a square brackets here, because we should put some arguments here. So what type of tree we will prelocate this? Can we do like this? Yeah, we can. And 332. And we also can do like this. And so using these two type aliases, we're returning back to our initial solution with, you know, with two type aliases with any type. Okay, so but what can we do instead of? What can we do in this case? So basically, we know that inside a post form, we don't have a files. So inside a post form, I would like to allocate, to create, let's say, tree with the data inside it with a strings, with a slice of strings. Let me check. Okay guys, so I'm thinking that I have to go because Slack, you know who wrote me in a Slack? The company I work for, and I need to fix one big feature, one big bug, which happened on the production as usual. So I think we are done for today. But currently I'm working on a Rust SAPI, so I can't. So unfortunately I can't stream this during the work day. But definitely tomorrow we are going to continue our implementation of this kind of stuff. So basically, what we currently have been done. So we currently. And what is the goal of reorganizing this kind of stuff? So basically we have two super similar functions, parse multipart data and parse post form. Parse post form uses inside it a slice of strings, because it's just a string we can just parse. Throw away Rust, we need go dev on RoadRunner. So if you know, I work on the RoadRunner in Rust, so you can find these repositories in our organization. So Rust and RoadRunner is the future from my point of view, and I'm already working on it. So yeah, parse post form, and so as a result we have a slice of strings. And if we have multipart data, inside the multipart data, we can have files for sure, because it's like multipart type of request. And inside multipart, use basically the same logic, like they are entirely the same, related to the parsing, related to the everything related to the underlying mechanisms, let's say like this. Except that we accept in our functions like push or mount to make a recursive call, we accept string or sure. File upload. So this is in all other aspects, all of this kind of logic is pretty the same like as to logic from like, you know, post form and multipart data. And my goal for tomorrow is to, using my imagination, you know, we are all programmers who can tune on imagination, somehow merge all of this kind of stuff in one using Golang's generics, which is like, I hate this notation actually. So I don't need to I don't want to use a predefined types here. So I think at the end we are going to use some kind of structure like this in the underlying type. Yeah, so a super interesting moment and I have to go. Okay guys, thank you very much for being with me and see you tomorrow and have a good evening and bye bye guys.